Hi guys, so welcome to the first video of 2022, on the channel. So I'm back at work today. It's the 3rd of January. I know in the UK in some places it'll be a public holiday because, like, if you have a public holiday like New Year's Day on, like, for example, a Saturday, they give you an holiday on a Monday. But they don't do that here. Like, we have I think we have 19 public holidays a year, but if it falls on the weekend, it falls on the weekend. Yeah, that's just it. You don't get like another spare one because it fell at the weekend. But anyway, our big Christmas celebration is coming up on Thursday. 4th, 5th, 6th, 7th, 6th actually it comes up on. So it's like that's Dia de los Reyes, Day of the Kings, and this is when the kids here get presents, so it's nice actually. It's like they do have Christmas here, but they don't celebrate Christmas in the way like we did in England. So what happens tonight is you have these huge floats coming down through the town and all the towns, and on them are like the three kings all dressed up like like the three wise men, basically from the Bible. I think it's called Epiphany or something this date in the Christian calendar, but not being Christian, I couldn't really confirm that. But anyway, what happens is, so the floats all come down, and there's all people lining the streets, and they go to like the town square, and then like what's happened is like the parents have given gifts to the three kings to give to their children. So when the float all parks up and it's covered in gifts and stuff, and then the three kings call out the children's name, and the little children go to the float and get presents. So like Santa Claus actually does exist here. He comes on the big float. Well, there's three of them. Dia de los Reyes. I think it's a great idea. So that's Wednesday night. So Thursday, of course, is a public holiday because everybody's celebrating, and they're probably all feeling a bit rough, apart from the little kids. They probably just enjoyed the presents. So anyway, I've chatted, man, 2 minutes or more. Let's do some work, So this is a motherboard I was looking at before Christmas. Well, I think it was about the 12th of December. I looked back when I looked at this. So this one, basically, I had no Vcore. Eventually, after first of all replacing a couple of one short circuit capacitor actually, down by the VRM controller. I still didn't have any Vcore, and then I took the VRM controller off the board. What's that? VRM controller. I don't know why I struggle to say that. So the VRM controller came off the board, and I cleaned all like the corrosion, the rest of the corrosion off, and put it back on, and it was working, sort of. So Vcore was going on and off, on and off, on and off. And that's as far as I got to, and the Vcore was going up to about 1.7, and I actually thought that was too high. I thought these processors, 4th gen, Intel I, whatever's about 1 to 1.2 volts, somewhere in that region, maybe a bit less than 0.9 volt or so. So I thought, oh well, maybe there's a problem in the feedback circuit here. So we looked around at that if you saw the video, and I found a bit of an odd resistance. When I took the resistor off, it was reading correctly. And that's as far as I went. I said, okay, I'll order one of these. And then I published the video. There's a lot of interest in this video, so I'm going to go back through some of the things that some people suggested and said. Just before I do that, just mention I've got a different camera set up now. I've positioned same camera but differently positioned for the inset. With me on, and different microphone set up with the DJ mixer. So let's see if this is working any better. And I've kind of got it all off the desk, so I shouldn't. If I like bump on stuff, you shouldn't hear like a lot of thunder. I don't know. I'll have to try when I play this back. So just mention that. Anyway, back to the plot. So quite a few people suggested things about this board. So let's have a look at the things they suggested and let's see what they are. So the first one, subscriber named Ralph J, said that at 1 hour 23:11 he thought there was a resistor or a component here with a blown centre. And I know what he means, so let's have a look under the microscope and we'll just look at that first, and then we'll go to some of the other suggestions. One moment. Okay, so this is the actual resistor, the one that Ralph was mentioning. I'll just Get the glasses off so I can see. So it's this resistor here. No, sorry, it's this one here. And this is actually one of the resistors that I originally thought had like the missing end cap. I'm just to focus so you can see it clearly. There we go. Yeah, this one. It'll focus. Yeah, got it now. Okay, this one. So this is actually one of the two resistors I thought the end cap was missing. But it isn't, it's just tarnished. And what you were seeing, Ralph, in the middle is like this dot where it's a 1.0, and that's where you think it's blown out in the middle. Admittedly, on the other video, it wasn't as sharp as that, so you wouldn't have seen it so clearly. If we go to this resistor, and you can see this end of it actually comes down to here. Yeah, you can see it's reading 1. So that resistor is actually reading fine, yeah. The other one that I actually had to resolder was this one here again. And this one I think actually goes to this point and here. Yeah, and that's also reading fine. So those resistors are actually good, yeah. So that's that one out of the way. And it was probably like that before, why you couldn't see it when it wasn't focused. Well, yeah, it's focused again on that one now. Okay, so that was that. So then Robbie Robson came along and made a few suggestions. So let's have a look at his suggestions and work through those. And I just mentioned, by the way, you probably could see on that last when I was on with the microscope, I've replaced the 56k resistor that I removed in the last video, and I replaced the little capacitor as well. So that's all back as it should be, yeah. So what Robbie, what you were saying is a few things. Well, first of all, you were asking, is it possible the CPU is faulty? Well, in actual fact, I tried 2 different CPUs on this board previously, but I didn't actually try a known good one, and that's what I have here now. So what I have is that this is an i3-4130, which is a known good CPU that I've used on a number of other boards and other videos. So we've got a known good CPU here. So let's have a look to see now if the power stays on with that CPU. I've not got the heatsink on the CPU because the Vcore is coming on and off, so it wasn't getting warm anyway. It hasn't got any power for most of the time. But if I put this here, you can actually see what's happening with the cycling of the board powering on and off. So let's go on to Vcore. I've just gone to the top end of one of these low side MOSFETs. Yeah, there's 3 phases, so it doesn't matter which one I go on. In fact, just to prove let's go on that one. Makes no difference. Yeah. So let's power this up and let's see what actually happens. So you can see Vcore is coming on and off the same as it was previously, yeah. And it's going to about 1.6 something. It goes to about 1.7 if I hold it. So Vcore is still coming on and off. And like you can see, I just put the hold on the meter. Okay. Yeah, 1.696. So that's the same as before I changed that 56k resistor. So that's what's happening with Vcore. Something else that Robbie suggested is, does the board stay on with the 12 volts disconnected or with no CPU fitted? Okay, so let's disconnect the 12 volts and let's see what it actually does. Obviously there's no point in measuring Vcore now because I've got no 12 volts, so see what it does. You see on the fan, so it's come on, it's switched off and it stayed off. Oh, this is still held on 169, by the way, if you wonder why that's still got that on there. So without the 12 volts, it comes on once and shuts off and stays off, yeah? That's what that does. Reconnect the 12 volts. I'll switch the power supply off at the moment. We'll take the CPU out, so this is your other suggestion, is what happens without the CPU. Let's see if we do any Vcore. So this is back on Vcore. Power supply is on, no CPU. You can see the fan. So we did get Vcore coming up and going off. Yeah, exactly same. And it goes to the same voltage. Let's have a look. Okay, let's hold it. It's going slightly higher, which is kind of what you'd expect if there's no load. I mean, we're talking very slightly higher, yeah, 0.3 of a volt or something like that. So that's what it's doing with no CPU in, compared to a good CPU. Something else you suggested, Robbie, was to check the power good signal coming from the VRM controller. Somebody else also suggested a very similar thing, so we'll look at that in a moment, but we will look at that suggestion, okay? So that was Robbie's main suggestions. Infinity 25, I mate. So you come along and you were saying you're a bit surprised I hadn't checked the USB ports for damage. So this will often happen if you've got a damaged USB port, you've got a short circuit basically, and that can effectively cause these sort of problems, boards powering on and off. Okay, so let's have a zoom down and let's have a look at these USB ports and make sure they're good. I didn't check before. That was actually, for most of the time previously, I had no Vcore at all. The Vcore only came on after I solved the original couple of problems. So we can see that these are looking absolutely fine, yeah, and some more just over by the PS2 connector, and again they're looking fine. So the USBs are fine on this board, but that is a very good suggestion. I mean, that is known to sometimes cause boards to power on and off, but effectively what's happening there, you've got an overcurrent, so the power supply shutting down basically. Okay, so that's looked at that. Then another guy, DI or DINF. Interesting to know what that stands for, if it stands for something. Anyway, I'll call you DI, yeah? That sounds Welsh to me. You're going to tell me it's not, yeah, DI. Anyway, I think it means man in Welsh, you know. I don't know what stupid things, yeah. Okay, so, yeah. What he suggested was a couple of things. First of all, he says that for boards of this type, this generation, 1.7 volts on the Vcore at boot is normal. It's not an over voltage. So that means really me thinking there was a problem with this giving too much voltage and that's why it was shutting down is actually not correct. Okay. I mean, I did order some of the VRM controllers, but I'm sure they'll get used for some other job. They'll just go into my stock of parts, and I'm sure at some point or other I'll need one, yeah. So okay, thanks for that, mate. So that's given me some information. You know, I'm still learning, the same as a lot of you guys, and thanks for that useful bit of information. So knowing that, he also asked, and this is kind of what Robbie said, is do we get a VR ready, yeah, signal from here into the SIO, which is this chip down here, and then does the PCH, which is under here, respond with the power okay, yeah. I've taken this off, by the way. I'll just show you. This is the PCH, so you can see where it is. And what I do notice on here, this obviously been running quite warm, but you often find this where it's like the heatsink compound in the middle is kind of gone. I've wiped it off a little bit, see if there's any part number on it, but there really wasn't much on there. So that could be related to the problem, yeah. It could be a problem with the PCH, but there definitely wasn't much in the way of heatsink compound on here, okay. So this is asking them basically, two are asking about the power ready. So let's have a look at that. Let's have a look at the VR OK or VRM OK signal coming out of here, and then let's see what that's doing. So the easiest way to find this is going to be using board viewer. Okay, so this is the board view, and by the way, all these board views and schematics are on the Learn Electronics Repair Discord server. It's linked in the description to this video and all the latest videos, and it's free, yeah, so come on and get there. There are thousands of GPU and motherboard and laptop and phone and all sorts of schematics and board views being loaded up there now. And if you've got some of your own, please add them, you know, to the collection. It helps all of us. But there's already thousands there, yeah, and they're for free. So if you want this, that's where to get it. Anyway, there's on the board view, this chip, this is the VRM controller for the Vcore, yeah. And while we're at it, this is the PCH, and this is the SIO, the Super IO, Platform Control Hub VRM controller. And these three chips together are responsible for powering the board up and starting the power supply to the CPU. This is your CPU, okay? So these three chips are working together to do that. So what we're interested in, thanks for a couple of suggestions, is the power good signal coming out of this chip. Yeah, we know now it's generating Vcore, but it goes back off again. And just one moment, phone's ringing. Okay, sorry about the interruption. So basically, what we were looking for is the power good signal coming out of this chip. So we know effectively the VRM's starting up, but do we get a power good? And by clicking on the chip, you can see all the various pins down here, yeah? And looking down through these, there isn't actually a pin called power good. Okay, what there is a pin called VR ready, voltage regulator ready, and this is almost certainly the power good, this one here. Yeah, so let's have a look where that actually goes to. Well, it goes to two resistors here. Does it go anywhere else on the board? No. So it goes to these two resistors here. Okay, this one is a 0 ohm resistor, so it's just a link, and the other side of the resistor is power good, pulse width modulator power good, VR ready. It's just a link. They're the same thing. It's just that the other side of here they call it something else. You'll often see that on board fuses and schematics, that the same signal, other side of just a piece of wire effectively, is called something else. Yeah, don't let that confuse you. So VR ready, power good. Yeah, and that's this resistor. Okay. There's another resistor. What's this one do? Oh yeah. Okay. So this has got VR ready. It's connected to this point. And the other end of this is just connected to 3 volts. It's saying here 3 volts. So this is a pull up resistor. What this does effectively is make sure that there's 3 volts on this signal unless this chip pulls it low. So if the voltage regulator isn't ready, this is 0. When it is ready, this kind of just lets go. It just takes the 0 away but doesn't put a voltage on itself. That's what the pull up resistor does. Yeah. So that just disconnects a pin from ground and then just takes it up to 3. Yeah, that's what's called a pull up. So this point here, let's see where it actually goes. Yeah, and this is the other side of the resistor. Yeah, the other side of the resistor. There's another resistor here, but I also notice it goes off over here. Yeah, and these are next to the PCH. And it goes to the PCH. You see the yellow dot here? So it goes to PWM power good in the PCH. That's exactly what we're interested in, yeah? So what we want to know is, does this power good signal go high? Yeah, when the thing powers up. Okay, so on our board, it looks like the resistor isn't actually fitted. But I don't think that's like been removed. And if you look around here, there's lots of components not fitted, and this is quite common on motherboards. I mean, without having another known good one to compare with, it's a bit impossible to say. But this is where we should be able to pick up the signal. So we can get onto here. I've got the black lead clipped to the ground. So let's now power it up. I'll put the CPU back in as well, and let's see what happens on this ready signal. For some reason it's not power on. Switch the power on. That's a good reason, isn't it? For some reason I haven't switched the power on. Okay, just get onto here 1 moment. Okay, well. So you can see it is going. It's up to like 3.3 volts or something like that. Yeah, 3.36 volts. Okay, so we do have that, but it's coming and going. It's going on and off with everything else. Like the whole board's powering on and off. I mean, to be quite honest, it's, you know, the ATX is switching on and off. Everything is going on and off. So let's have another look back at the power on sequence. See if we can figure out why everything's actually going on and off. Oh, it does look, by the way, that this component probably isn't fitted. You see, if I hover the mouse over here, or if I click on it, the capacitor, up here it's telling me it's a 0.1 microfarad 16 volt, yeah? But if I click on this one, it doesn't say anything like that component doesn't actually exist, if you see what I mean. It's kind of like blank there. So I'm taking that fact that's saying that that component is actually not fitted. So I don't think it's missing at all. Okay, so let's have a look now at the power on sequence again and see if we can find anything else from this. So just 1 moment. There we go. Okay, so this is the power on sequence. Now we had a good look at this on the previous video, but if you didn't watch that one, let's just go through it again, and this time we'll go through the whole thing. Yeah. So we start off just by following the steps 1, 2, 3, and so on. Yeah. So step 1 is that there's 5 volt standby on the power supply. Obviously, your ATX is powered to the mains. You've got 5 volt standby. Yeah. And the 5 volt standby generates some voltages. So through a FET, a regulator, it gives you 5 volt dual. Yeah. Through another one, it gives you 3 volt dual. And it also gives you 3 volt dual PCH, these voltages. I don't really know what the difference is because they both go to the PCH. From this as a circuit, D power OK, so that obviously gives a power OK signal to here as well, yeah? And when these voltages are present and this is present, this then sends 2 signals down to the SIO. Now, this SIO does not match the one on our board. This is off a gigabyte. So ours will be functionally similar. This chip is the same, yeah, but this isn't the same. So you can't say exactly this will be. But I suspect that these signals will go to our chip, yeah? And these are the sleep signals. Sleep state 3, state 4, state 5. So these are the signals that effectively, if you put the computer into standby, so like in Windows, you go into standby or suspend, yeah? That's how it's effectively, when it shuts down, tells the SIO it's in standby. So when you power up, it'll come out of standby rather than coming from a cold boot, yeah? So that's what these signals are actually involved in. Okay, so number 7 is your power button. So when you press the power button, the SIO sends this signal back to the PCH power button switch, yeah? It says that's pressed, okay? It also sends the PS on signal to the ATX power supply. This is the green wire. So it grounds this wire, yeah? And the power supply turns on. It would appear that our power supply is actually turning on and off. In fact, we know it's turning on and off. And we can just look at that green wire to prove it, yeah? So when the power supply turns on, main power comes on, yeah? That comes into here, and this is your VRM controller. Again, ours is a different chip to this one, but it's basically doing the same job, yeah? So this starts up, generates Vcore, and it gives a signal like VR ready. And this is a signal we were just looking at. And that comes back, according to this, comes back to the SIO. But on our board view, it doesn't appear to go there. Or at least not directly there, but it does go to here. So this step 13 signal to here and 14 signal back out of here to here may and ours just be one, yeah? I mean, we have a different chip here, yeah? So it's possible ours actually doesn't have the 13 and 14, it just sends a signal straight to here. In fact, it does definitely go to here, yeah. We can say that much. But we can carry on a bit further. So when we get to this point, we now get step 15. So step 15 is ATX power good. This is the grey wire from the ATX power supply. Comes through some sort of circuit, yeah, and generates a power OK signal into the SIO again, yeah, that's 15. Number 16, IT power OK, goes to O power OK up here, yeah, so they're sending power OK. It now switches on the output clock, yeah, 17. And I'm assuming that this block here of various VR ready and power goods and signals is also generated for me at the same time. VRM power good and such like, it kind of, all this is 17, I think. So the clocks come on and this comes on, yeah? So we've now got power, we've now got the clocks running. So next one, CPU power OK to the processor, 18. And platform reset back to the Super I/O, sends those two from the PCH, yeah? 20 is the CPU reset, so it takes the reset off the CPU, so the CPU can now start to execute code from the BIOS. And this 21 effectively takes the reset off all the PCI slots, so all your various cards in the PCI slots can now start talking to the computer and saying, I'm here and this is what I am. And I'm not sure what this chip is, actually, RTL8111F, I'd have to have a look. Platform reset, but it sends it to that as well, yeah? I'm not sure, I'll have to see what that chip is. But that's the entire sequence. Now, what we had originally was no Vcore. Yeah? This was getting enabled, but nothing coming out of it. What we seem to have now is we've got Vcore, but the main power is going on and off. So let's have a look at the signal PS on here, yeah, and just check that that's what's happening, that the SIO is switching the power supply on and off, yeah. Let's go back over to the camera, let's have a look at that. Okay. Moment. There, okay. Let's move the microscope out of the way because I don't need the microscope, and let me just zoom that out a little bit. Okay, so let's have a look at the green wire on here, yeah? Let's see what's actually happening with it. So it goes low to switch on, and then it goes high again. So in actual fact, the SIO is continually switching the power supply on and off. Oh, did I do something different because I touched it? That's interesting. I touched the SIO and the thing's come on. And we've got Vcore. But it's not bleeping, it's not booting. Well, that was interesting. I just touched that, yeah, I touched it. At that point, it's actually come on. The CPU is warm, but it's getting warm now. The PCH is getting warm, but not hot. Okay, I've switched it off again. Let's just put the heatsink on the chip. Unfortunately, now you can't see the fan going on and off. I'm sure you can hear it. Let's switch it on again. So we'll switch it on. Yeah. Powered on and off. Push on this. No, maybe that was coincidental. Is that right? Yeah, push on the PCH and that's got it. PCH, but it's still not running. Yeah, I don't get any bleeps. I can check if I get any. Well, I won't get any pictures. I'll have to put some RAM in. But let's just test it anyway. Okay, yes, I can get it to do it. I can't get a picture out of it, but by pushing down on the PCH, I can get it at least for the fans to come on and stay on, and for Vcore to come on and stay on. But it doesn't boot. It still doesn't work. Yeah, but that definitely seems to be sensitive to pressure on there. I've got a bit of a push, and it'll do it. But I just want to look at a couple other things around here as well, which will kind of come back to here. So let's have another look at the startup sequence again. Okay, let me just go back over to the startup sequence. So here we are. This is the startup sequence. Now, the problem we have is at stage 9, this is going on, off, on, off, on, off. Yeah. So you would assume that whatever's causing that to go on and off repeatedly is a stage previous to this. Yeah, one of the earlier stages. Well, stage 8 is sending this signal out to here, yeah, and 9 out to here at the same time. But what we have previous to this happening, after stage 4, this powering up, we have these two, 5 and 6, the sleep states coming into the Super I/O. And I'm wondering if actually what's happening is, when it's not working, that the sleep state is going on and off, yeah? So let's have a look at that and see if we can determine anything from it, just out of interest, really. So this is actually the data sheet for the PCH. So the PCH, if I go to the here and the PCH, just clicking it somewhere, you can see it is a DH82H81. That's the port, yeah. And if we search for that plus data sheet, then we find this data sheet, okay. And it's quite a long document, but this is the actual Intel datasheet. I'll put this onto the Learn Electronics Repair Discord server, yeah, so you can download it if you want it. I think we're on page 112 or thereabouts where I was before. Just go. I wasn't this far down it. Just find that page where I had before. One moment. I'll find it. Actually, I'm sure it was about 112, 150. Let's have a quick look. So about power state, power management operation. I think it's a bit previous to this actually. That was before the SATA. Okay, let me just find it. One moment. Okay, so what I'm thinking, I'll show you on the data sheet to the PCH chip. There's a couple relevant parts here. I mean, it's a very long document, like 800 odd pages, but it's mentioned here about power management. I think this is what's happening. I'm going to see if I can prove it. Yeah. So it's saying that software initiates the transition to sleep modes S3, S4, S5 by performing an I/O write to the power management control register in the PCH. So effectively, the processor sends some data. It accesses a register inside the PCH. Yeah. And after it writes that, then the PCH starts to shut everything down. It's basically what this is going on to mention about then is sending turn off messages to all the various like PCIe cards and whatever, yeah, and then go to shut down. So that's there. So what effectively puts the platform to sleep is software. Okay, that's the main thing. Now the other interesting part, I think, is on page 162 or 172. Let me see if I can just find it, and it explains this a little bit further. And this is what I think we can actually prove using the meter. Okay, so a little bit more. System power planes. A little bit more. Where we find it. We're talking about clocks. I think it's a little bit further on. Sleep states. Okay. A bit more. I'm sure there was a particular page I want to find for you and show you. Let me find it again. One moment, guys. I can never find it when I'm looking for it. I know it's here somewhere. But typically, it was just a little bit further down the page, yeah. So here we are. System power supplies, planes, and signals. Okay. The power plane basically means like there's different voltage rails. So you've got some voltage rails there when the computer's running, some are only there when it's in standby and such like, yeah. Now it's mentioned about these sleep S3, S4 and S5 signals, and they're all active low. That's what the hash afterwards means. So if that signal goes low, it's active. So sleep S3, state 3, can be used to cut power to the system core supply. Yeah, this will be the CPU. Yeah, it only goes active. So this goes active in suspend to RAM state. Yeah, so in this case, effectively the system is suspended to RAM, so it cuts the CPU power, but it leaves the RAM powered on. Yeah, cutting the power to the core may be done using the power supply. I mean, that's almost simply by switching off the 12-volt signal that comes down on the little 4-way connector to the motherboard. Yeah, or by external FETs on the motherboard. Yeah. Right, sleep states 4 and 5 used to cut power to the system core supply as well as power to the memory. Yeah, that goes on about that. Yeah, and sleep state 4 is used to remove power from additional subsystems. Okay, so depending on which of these signals go low is what puts into sleep state. And I think that's what our board's effectively doing over and over again. Now let's see if we can actually prove if that is the case. Okay, so this is the PCH, yeah, and if I click in here and I scroll down, but we want to find these sleep 3, 4 and 5, yeah, let's see if we can just find all the, here they are, yeah, so sleep 3, yeah, is there, and it goes to a resistor here. Does it go anywhere else? Yes, it goes down to the SIO. So these 3 components here, yeah, are sleep 3, and we can manage, they're all connected to here, yeah. So we can check sleep 3 here. I want to see if that's going on and off. Okay, so get the other ones, sleep 4 and sleep 5. So sleep 4 was probably the next pin to this one. Sleep 4, okay, that also goes to the SIO, but it doesn't go to any resistors. It goes to the 6th pin up here, yeah, so we'd have to measure that on the pin. Where's sleep 5 go? Let's have a look. Sleep 5, it's here. Well, that goes to a resistor here, but doesn't go anywhere else. Yeah, we can check on the other side of the board. Let me just go to the bottom. No, it doesn't go there. Back to the top. Okay, so this signal only seems to go to this component, which is what, a resistor. And the other end of the resistor is ground. Okay, so this is a pull down resistor, yeah, which basically just holds this signal. I assume it's down. This end's ground. It looks like there's no resistor even there. Yeah, it doesn't do anything. Okay, so that signal, sleep 5, just doesn't do anything when it's high or low. It's only sleep 3 and 4 that we're interested in. So let's have a look at once again where they were. So I'll find them in the chart. I'm sure I've just clicked off it. Where are you? Sleep 4. I've clicked off it somewhere. I'll just find it again. There's one of these resistors. I know where to find it. I know where to find it. 1, 2, 3, 4, 5, 6 pin up here. Okay. Find it the easy way, yeah. So we're interested in that signal, sleep 4, yeah. And we were interested in the signal sleep 3, which was, I know where it also was. It was on these resistors here. Yeah. So let's have a look here. And let's have a look on the 6 pin up here to see if these sleep states are going on and off. Because if they are, that's what's switching the power supply on and off for sure, yeah. Okay, let's have a look at the, get onto the microscope and let's look at that. Okay, so on our board, these are where the 3 resistors were, if you like, but it looks like only one of them is actually fitted, and you can see it goes to pin 2 here, yeah. So just get the probe on it properly. Yeah, I'm on there. So this is the sleep state 3 signal. Let's just get them, you can see that, okay. So let's see what this is doing. I'm expecting this is probably going on and off. Oh, I think I might have lost the ground connection. Hold on 1 second. Just, yeah. This is when I tried the monitor, I disconnected the ground lead from the meter. Right, it's back on now. Okay, let's go forward again. I've just switched the power off. I'll just down the microscope again. So there we go. We're on there, yeah? Power on. So this should go high. It is high automatically, okay. And it should stay high. If it goes low, which it's just gone low, it's putting the machine effectively back into suspend to RAM state, yeah. And it shouldn't be doing that. The only way it should do that is if, like, the processor is writing and registering there, but we know even with the processor not fitted, it still does the same thing, yeah. I can prove that on this signal here, but we know it goes on and off. Okay, so that's that one. Let's have a look at the other one, which is pin 6 on the chip itself. One minute, let me just get on there. When I say pin 6, I mean the 6th pin up from this end, but it's not pin 6. Again, this is high, and it should stay high, and it's going low. Yeah, that's definitely the PCH telling this chip to switch off the power supply. We've just found it from the data sheet. We know that's the case, yeah. So what seems to be happening is if I push on this PCH, I can actually get it to effectively stop doing that. Let's see if I can do it. So power's on. I'll put some pressure on. You'll hear it. It might take a few times. I'll just pause the video. Okay, it took me several times. At the end, I think it just did it on its own. So the fan's actually running now. Let's have a look what's happening then on this resistor down here. One moment, it's this one. Yeah, that's high, and it's staying high now, yeah? Okay, and then the other one is a 6 pin up on this chip, so I'm a bit dubious at getting a good connection at it, but it powered up actually. I have to adjust the focus for myself, and I'm able to get onto it. 1, 2, 3, 4, 5. Pin 6. Okay, and it's high, yeah, and it stays high. So, okay, that's taught us something. Let's have a think about what we've learned. So, it appears we have a problem with this PCH. Sleep 4 only goes from here directly to here, as you can see. There's no pull-up resistors or pull-down resistors, yeah? So, that must be connected. Otherwise, it wouldn't be going up, down, up, down, up, down. I don't think it's a case of when I'm pushing on this that I'm actually getting it to effectively make a connection on that particular signal, if you see what I mean. It's connected all the time because there's no pull. If there was a pull-up somewhere, you could accept it. But the fact is, when it's not working, it's going on and off. It's being driven. And the same applies with the Sleep 3. There's a couple of resistors, but I had a quick look on the board view, and there's no pull-up resistor as such. So this chip's actually driving these signals low, yeah. So it looks like either we've got, you know, a broken ball somewhere in here, somewhere else, but not on that pin, that effectively is stopping it from working. When I'm pushing down, it'll work. But the last time I didn't have to push down. I just waited a little bit, I'm just going to test this again. Just give me one moment. It'll be a second for you. Let's just see the fact. Well, as luck would have it, I can't get it to do it again by pushing on the chip. But from what I can see is happening here, basically, this chip has supply from the 3-volt battery, yeah? And we can measure that. If you look on the board, you can see there's a 3-volt battery supply going here. It has a 1.1 and 3.3 volt supply coming here from the power supply. And what appears to be happening, as far as I can tell, and I'll show you, is that I'll just put my test meter on. The 3.3 volt from the battery is here, and you can measure that. It's on some of the components up here somewhere. I'd have to go find it on the data sheet again. In fact, you can see it there. Yeah, that's a CMOS battery on the chip itself. Okay, so it's got battery power, and those sleep states are going high. You've then got this one coming and going. This is the 1 volt supply. Yeah. And this one is somewhere the 3.3 volts. I don't think it's here. I think it's here. Yeah, from the power supply. So it seems to me that we've got the voltage from the CMOS battery here all the time. Yeah, it's actually a little bit higher on here, strangely enough, but it's there all the time. Actually, that might well not be from the battery. That might be, you know, from that 3.3 volt dual we're looking at. Yeah, that goes to the chip. And it appears that when the other voltages come on this, that then the sleep states go low and it switches back off again, which is suggesting to me it's a faulty chip. The fact I managed to push on it made me think maybe rebull it, but I suspect it's the chip. Let's have a look to see if I can get a stencil for this. I don't have a stencil for it. If I can get a stencil, it's cheap. It might be worth me trying to rebull it. If not, it might well be worth me ordering a chip, and let's see if that actually fixes it. Okay, well, while I was looking for a stencil, I left this just switched on actually. It wasn't touching anything, and after a couple of minutes it just came on. So you can see now it's powered up, and I actually have Vcore 1.7, yeah. Processor's just a little bit warm, it would get warm eventually. This is quite warm, maybe it's when this warms up it starts to come on. So Vcore's there all the time now, yeah. And those sleep states, when we had a look at them, we can say with confidence that the sleep state is there all the time, high. Just go on to it. 3.4, yeah. So it will do that after a time, but it still won't work. It doesn't bleep, it doesn't boot, nothing happens. Yeah, we don't get a picture. Okay. So I think that again can tell us really it's this. I don't think it's reballing. It's after the thing itself. It's not hot like it could have expanded and touched the board. I mean, when pushing pretty hard on that, I think it just effectively at some point decides to go a bit further, but it still doesn't work. Yeah. Okay, so I can get stencils for this for about €2. Yeah, something like that. I can get replacement chips for about 20, or just a bit under. I do have another board, which I'm going to look on the next video, which is this one, which is also a H81M. This is one that had smoke coming out for me last time we tried it. So let's look at this one as well, and from that we can also have. This has got the same H81 PCA, exactly the same one under here, I'm sure. I've had a look at the board here and it says it's the same one. So we could, depending on what's wrong with this one, use a PCH off here. But what I'm just going to do first, and before we end this video, is I'm going to remove the PCH from this one and make sure it comes off cleanly without damaging any pads on the board. Otherwise there's no point replacing it. Yeah. So I'll just get the chip off and let's have a look to see what condition the board's actually in. So first of all, I'm just going to add some flux to this, so kind of like warm it up a little bit so it runs underneath the chip. That's the idea. Of course, that tended to go over the top of it as well. And we'll just go round a couple of times, just flux down by the side, a bit of heat. Okay. by the side again. Bit of heat. And I can see that flux is running down behind the chip quite nicely. Go on the fourth side. More flux. Just try and get it to run down behind the chip. Okay, so that's some flux on that. So I'll put it on the machine. I'll try this on the mobile phone, so I've got a camera over by the machine. Okay, so it's on the BGA machine there, ready to be taken off basically. I find the problem with the BGA rework, this is my experience, is it's like, with this machine, it's like very easy to repeat the same result, but if you're working on lots of different boards, it can be very difficult to get the profile right in the first place. And if you get it wrong, then either it won't unsolder, you'll burn the board if it's too hot, or if you're well unlucky, it'll be almost hot enough but not quite hot enough, and it won't lift the chip. It will lift the chip, it'll take some tracks with it. So we're going to choose a profile. I'll put a few profiles in this one. This one, lead-free stubborn, is one I did for some BGA chips, a bit more tricky to get off. So this takes up to about 250 degrees, which should be hot enough, but you know, we kind of have to just hope that is, yeah, it is going to be right, because once I do it, that's it. It's like fire and forget. Yeah, so we're ready to go. So we're going to tell it to remove the chip. Yeah, we're going to tell it to run, and now we'll just get on with it. So there's nothing else I can do now. I've done what I can do. I've put the profile in, hoping it's the right one. And so this is the problem when you're working on lots of different boards. If you're working on the same thing over and over again, say like PlayStation or something, and you're repeatedly working on the same board, it's much easier to do this, yeah? So okay, we're on. And now it's just a matter of letting it warm up, and it'll do the job in about 2.5 to 3 minutes, yeah, something like that. It's just saying it's heating and it's going. So like the pale blue line is the temperature sensor I've got right next to the chip. The dark blue one is the preheater underneath, which is set to go to 200 and stay there. And then the other ones are red and green, which are tracking each other. This is the upper and lower heater basically. So there's like another heater, you can probably see it down there underneath the board, yeah, which I can actually adjust. That's just bring it a little bit higher up. Yeah, it's quite close to the board now. Okay, so yeah, let's just let it do its job. I'll pause the video and I'll put it back on when it's getting near the end. You can just see, by the way, it's just reaching the first stage now, like the pre-soak. Yeah, you can see the temperatures on there. Okay, let's pause it. Okay, so you can see the upper and lower temperature of about 225. It's leveled up on this. The preheater's coming up 191. That's stopped about 200. The sensor's reading about 217, 218, about 220 now. But that doesn't always read accurate, I don't think, you know, and hot enough to actually say, yeah, it's going to desolder it. Normally that has to get up to about 250 before it'll actually do the job. And this is a case of, did I choose the right profile? There's not much you can really say other than that with this. We're 190 seconds in, 3 minutes over. So I think maybe sometime in the next minute it'll actually, either it'll desolder or it won't. So I'm getting close to the temperature to melt the solder. There's a bit of smoke coming off now, you can see from the, obviously from the, yeah, the smoke rising off it from the flux, yeah. But, well, let's see, we're getting close. I'm not sure exactly how long this profile runs for. You see the sensor's 228. So that's going to be just around the point where it melts the solder. Now it's going to push up again. And I think this is the final shove up. And it looks like it's probably going to get hot enough to desolder. Okay. It'll make a bleep when it goes, by the way, so don't be surprised when you hear quite a loud bleep come off the machine, and then we'll see whether or not. When getting down there, you might just see it's just bubbling a little bit now. You can see bubbling possibly underneath the VGA chip. Just hope those capacitors are not too close and they don't go bang, yeah. Okay, so we're getting up now. You see 240 now on the sensors. That's kind of like in the play zone. Yeah, okay, here we go. And it lifted. Okay, that was nice. Okay, so now we just have to let the machine cool down and let's see what happens. Okay, so let's have a look at the chip which you've just removed. So this is the PCH. And yeah, that looks pretty good. That looks good. Unless that's a problem there. Let's have a look at it. Normally if this goes wrong, it goes wrong in the corners, yeah, this is where pads get ripped off. But I don't think that's actually a pad. Yeah, this corner's got like a little triangle in it, yeah. And I think the other one just has like a little dot in it. So I think that's okay. Other than that, I don't see any pads that have come off the board and stuck to the balls. That's what often happens. You'll get some like orangey brown looking ones, and that's where they've actually brought the pad off with them. But all these look to be good to me, yeah. Yeah, they all look to be nice. Even the ones into the corners. Yeah, I'm pretty happy with that. It's just, you see the whole thing there. Yeah. I don't think there was anything wrong with the balling under this chip, like reballing would have helped. I mean, that's come off almost like it's been reballed already, yeah. So look at the board. So if that's come off well, this is probably going to look alright. And the first glance, that was pretty good. Now let's zoom down a little bit. Let's have an actual look to see what we've got here, yeah. So here we go, some focus. So once again, all the pads seem to be perfectly fine. The balls haven't even run together, which is you know, something that happens, to be quite honest. But these all look to be very nice. Yeah, it's come off very cleanly. So have a look at these ones around the middle. These like mainly the power pins. Yeah. Okay. So yeah, I have to say, guys, that is almost like a textbook example of how to do this. I think I'll say it myself, but that's very good. Yeah, that's good. This sort of work, it takes practice. Yeah, it takes practice. I mean, you've got two options. One's you usually effectively use like a manual hot air machine, but the problem with that, it's very difficult to get repeatable results. Yeah. The other option is to use a machine like this with profiles, but the problem with this is unless you're doing lots of boards of the same type, is getting the profile right, because it's like fire and forget. Once I hit that button, there's nothing else I can do. The skill is all involved in setting the profile. That's the skill. Everything else is down to the machine. It's going to do what you've told it to do, regardless of whether that's a good or a bad thing. Yeah, but this is spot on. I have other profiles, for instance, if I want to remove LGA sockets with lots of broken pins and fit new ones. I have hotter ones for that. I have profiles for similar work to this on heavier, like gaming motherboards, and I have profiles for GPUs, which obviously require more heat. You know, the different jobs require more heat. Okay, guys, so this is ready to have a replacement chip. I don't believe for 1 minute there's any point in reballing that other one. Not how clean this came off. I'm interested to hear what some of you guys think about that, but my honest opinion is there'd be no point in trying to reball the other, the chip that came off. We've got the other board to look at, which is another H81. So depending what we find with that, if it's got some problem that we can't fix, maybe we can take the PCH off that one and put it on this one, assuming the PCH isn't what's wrong with it. If it's also got a faulty PCH, we can order two. They're about €20 each, which for what these boards owe me, by the time I've paid the parts, I'll be lucky to get back the money. But you know, that's not really the point, is it? The point is learning to do the job. Yeah. Okay, guys. So I'll see you soon, probably tomorrow, with the other motherboard, and after that, let's decide what we're going to do with it. Okay. Adios, amigos.